Welcome back to Chat with Chief, and today we're going to go over SolidWorks and Fusion. So what you're going to want to do is open up SolidWorks, and when you're in, I'm going to go to the front plane, click Sketch, and click Line. Now I'm going to go off my origin, which is right there as you can see it. Go straight down, and then Escape. I want to click it, make sure it is vertical, and then green check mark. And then now I'm going to create another line from the origin as well. Go straight across, and then down, over, and then don't worry, as I'm doing the sketch, you will see me put a dimension on there. So we are going to make this little square piece, and then just go up slightly, give or take. Okay, so now as you can see it's crooked, so that's why you press vertical. Green check mark, and then now I'm going to dimension it 2.5 inches, 0.75, and then come down. This would be 2.5, and this one would be, say, about 4.25, and then this one will be 2 inches, and then green check mark. Now I'm going to close my box, and I'm going to select the arc, 3-point arc. I'm going to go here, click here, and make it a little dip. Okay, now I'm going to click Features, Extrude Base Boss, and I'm going to do a 1 point. Actually, I want this slightly bigger. As you can see, it doesn't actually look like what I am going to cut out later, but I'm going to go back in it, not to the sketch but the boss, and I'm going to make this 150 and actually 2 inches. Yeah, so that looks a lot better. It's starting to take shape now. All right, so I am going to fillet this corner, just 0.5, and then now I'm going to fillet this, but actually as you see it, I don't like that, so I'm going to go with a chamfer. Click this, and then it needs to be flat on the top. So what I'm going to do is change up the degrees actually to make it flat, as you can see there. And I'm going to make this 90 degrees. And as far as the distance, that's okay. We can leave it right there how it is. So green check mark, there you go. So now you have your piece, and as you see in the piece, there is also a hole in there in the center. So I'm actually going to go back in here, readjust some sizes, but it's okay. You'll know what I mean when I say readjust the sizes, because your pieces matter, the sizing. Excuse me. Sorry, I lost my train of thought. All right, so what I'm doing now is I click the inside. This is for the hole, and I'm making a construction line. There you go. Make sure these are all construction. If they're not, they'll show as a open-ended piece. And make your circle. This is going to be 1 inch. So there you go. Green check mark, features, extruded cut, and we're going to go through all green check mark, and there you have it, your piece. So nice and simple, easy to draw. These are the pieces that are going to clamp down the moose antenna, I believe, if I'm not mistaken. But make sure you save your work. I saved this as Solidworks Training, SWTRNG, and I'm putting it on my desktop so I can find it. And then also you want to save it again as a step file, which is right here in the drop down, and put it on the desktop. This is for Fusion, so that way I can upload in Fusion. Once that's done, go ahead and open up Fusion, and you're gonna go in File, click Open, go open in my computer, and then you're gonna click the SolidWorks Training to Fusion, as you can see here. Populate it right up. This is what I just drew in SolidWorks, as you can see here. Like I said, I made some minor tweaks, but for the most part, you can understand what I drew and how it translates into Fusion. All right, so now I'm gonna click top, highlight all, click move, and then I'm gonna make copies of this. So create copy, and then once you click that, I'm just gonna move it up slightly with this arrow. Okay, I'm gonna do negative 2 point, I like 2.50 actually. That's a better bet. Don't want them too close because I gotta cut them out. And then once it looks good, click OK. And then I'm gonna highlight all of them now. Right click, move copy, create copy, and then it should give me 2 more. And I'm literally just moving them directly on top of those other 2 because we're gonna be cutting out 4. Everything looks good, click OK, and then now you're still in the design phase, and to cam this you are going to have to click where design is, drop down, manufacture, and now this is for the cam portion. You can click new setup, and you are going to click on the orientation Z, and then I click the face, and then for the X I click the side. And then stock box point, this is where you are going to set up your work coordinate system, WCS. And then I'm actually going to click this corner because I like the top left. And as you see, I'm over here messing around with it. Just trying to make it right. So as you see here, and then click the face of the X back here, and then all right, box point, click that corner. Now I'm good to go, and flip X-axis. You have your G54 in your top left. That's how I like it. Now I'm going to set up my stock so that way it matches what I'm putting into the machine. I'm going to go to fixed size box, and on the X I'm going to go with 12. Do mind that clicked out. Back to stock, 12, and then the Y I'm going to make it, let's see, I guess 6 doesn't look too bad. So now for the position of the model, excuse me, clicked off of it again. Back in stock. So the model position is literally top of the Z, and I have it, the offset is 0. So it's, your part is sitting right on the top, like it cuts from the top of the metal. And I'm gonna change the, if you can see here, how I'm showing you all, the height is the thickness of your part. So the thickness of my part is 2 inches. Or my stock, excuse me. and then your X is your width and the Y is your length. And here are the different types of strategies that I plan on using for milling. So there's 2D adaptive clearing, 2D pocket, face, 2D contour, slot trace, thread bore, and etc. We're gonna go with a 2D contour. Why? Because I've used this before, but before you can actually go with that, you're gonna have to create a tool if you don't have a tool library. So in the plus sign, I'm going to be using a 1/4 inch end mill. And if you see here, it's already built in. Rule of thumb is you want to measure out your cutter. Every cutter is different. You don't want to just go with the default program because maybe your cutter below the length can be longer. You don't want that. You want to tell the machine exactly how your cutter is in the Cat 40 holder. So turning down the spindle speed to 4,000 because max RPM on a hot CNC machine is 4,000 RPM. It's a TM1. So my service speed, it calculated for me, Fusion, was 261, and I like that. So this is going to be my tool 1 1/4 inch end mill. Can't type today, and click accept, click select, and then from there you want make sure you work from left to right as well. Never right to left, always left to right. So right here, I'm in my geometry, I'm clicking the bottom because that's where I'm cutting it out, and I want tabs. I want 0.15 tabs, not 0.25. That's a little too much. So they automatically put the tabs where you want them, or they automatically put tabs for you, but you can also place them how you want them. So now we're in the heights tab. I don't need to mess with this because in my geometry, I already told it that I want it cut at the lowest level. So now we are in the passes tab. This is where you're going to tell the machine and how you want to cut it out. So I could do a roughing pass and the rest. So I'm not going to go with the roughing pass. Actually, I'm going to go with multiple depths. So I'm just going to take out the roughing pass, as you'll see here. And so it wants to go 0.5. I'm just going to go with a 0.125. Reason being is I didn't want to go more than 20% of the cutter. Like I could have did a 0.25 and then that's the whole cutter. So I just I do a conservative just to be on the safe side. So if everything looks good, go ahead and go to the next tab, take out lead-ins and lead-outs. I was just going with this because I don't want to crash the machine. It could not crash, but just for me, this is what I'm selecting. I added a ramp in there, and if everything looks good, go ahead, click OK, and watch your part. And you're gonna go up to the setup, or you can click the 2D contour, and you're gonna click right click, and you're gonna go with simulate right there. Watch it. If everything looks good, which it should, you'll be good to go. And this took a total of 1 hour and 1 hour and some change. Now that you have your pieces cut, you need to get them out because they're still inside the actual material. So you're gonna flip your part over just like this, and then you're gonna click new setup. And on new setup, you're going to click the Z at the top, and then on the X, I'm gonna click right here on the side. Not the edge, but right here on the side. And then you're going to click the box point, click the corner, and then just flip the axis. Now you have your G54. Stock you don't need to worry about because just from preceding setup, click OK. And there you go. So we are going to face this side now to get out those pieces. And I'm going to use a face mill for that. Or as we call it, a shell mill. So these are the exact measurements on mine that I have in the MWMSS. And cutting data, again, the machine is only rated for 4,000 RPMs, but for the shell mill, I'm just going to do 3,500 RPMs. It calculates the service speed for me. I'm okay with 40 inches per minute on the feed rate, and I named this shell mill for tool number 2. Click accept and select. Now you have your tool. Remember, work left to right, and I'm going to cut out the face. That's all I want, is the top. I don't want to go any lower because then I'll cut into my actual part. So you don't need to mess with the heights tab. Fine here. Those are face contours, and then of course I want to go multiple depths. And then the maximum step down, I will go and change that. Take the lead in and lead out. Click OK. Let's watch it. So I will go back in there and change the step down. So right click, edit, and then right here for the multiple depths, I'm gonna adjust the stock offset to go 3, because you see, as you notice, it was just cutting out the center. So now it's cutting the whole piece. That way I'm not just cutting the center of it. I want to make sure I'm trimming everything. All right. So as you see here, you're trimming everything. And that's going to take 40 minutes, which is not too bad. Back in there. And then I'm going to change this to the maximum step down. I'm just thinking in my head now, what should I change it to? So I just went with a 0.09, and I will show you the time difference. I went from 40 minutes to 22 minutes. So that's not bad. I can actually probably go a little bit more on the step down, but as far as that, I went from 40 minutes to 22 minutes. Now that everything looks good, right? You're going to post-process this. This is how you're going to take your G code and put it into your machine via a USB flash drive. So I'm going to name this 01001. You're using Haas, it has to be 01001, and etc. So for on setup 1, I'm not using a paid version, I'm using a student version. So I named it what I wanted to name it, and it's going to open up a G-code reader file for me, and I'm going to do the next one and set up to post-process again. This one will be 01002, and then in the comments I named it also, so that way you can see it in your machine. Click post, yes, and then to put it all together, because like I said, I don't have the paid version, I'm just going to highlight everything. Not to the ending of the G code, but as you see right here, go all the way down, and what you're gonna do is make some space right there, and Control V, just scroll back up to make sure you added the correct thing, and then if everything looks good, you're going to save this, and I'm just going to name it today's date, and I will send this to my flash drive to upload onto the hot CNC machine. So I gave it an extra name, SolidWorks Training, today's date, and click save. Minimize. Make sure your GP4 is set on your machine to include your tools on top of the part, and make sure your keys are 50%, 25% rapids, and watch distance to go, and you should be good to go. This is what it should look like, your job that you had just cammed, because of course you designed it in SolidWorks, real nice finish. We're now gonna place it back in the vise, flip it over, get GPT4, cut out the shell mill, and you'll see the pieces. Real nice.
Get off the bed.
Alright, this is how it looks, all done. And these are the pieces. Of course, you got to drill out the holes. But here are the pieces finished. The holes were drilled out, as you can see here. They're not bad looking. Came out pretty good. Here it is, you can see with the tabs. Yeah, not too bad. For the most part, I mean, look at it. Not bad, huh? Anyways, if you got any questions, please comment in the comment section, and I'll be more than happy to answer them for you. And then we'll go from there. Anyways, thanks for watching. All right, y'all.